All right, so part 3 of reproductive systems, female reproductive system. So, function, production of gametes, which are called eggs or ova. The singular for ova is ovum. To support a developing embryo during pregnancy, and what makes all of that possible are cyclic changes within the ovary in response to changes in hormones released by the anterior pituitary gland and changes in the uterus that are a function of changes in hormones from the ovaries. So the main internal structures for the female reproductive system are the vagina, which ends in the cervix, different color, which ends in the cervix, which is at the base of the uterus. The uterus is a 3-layered structure. It has a serous membrane on the outside. It has what's referred to as myometrium, which is smooth muscle, and then endometrium, which is the part of the uterus that most folks are familiar with because that's the part that is hormone sensitive, builds up during the uterine cycle. So a single vagina, single cervix, single uterus, but 2 fallopian tubes, which are also called uterine tubes or oviducts, and they end in these enlarged areas called fimbria, which is Latin for finger. The ovaries themselves are not, and I repeat, are not directly attached to the fallopian tubes. This is the ovarian ligament that sort of anchors them in place. So if we look, smaller image but with more context around it, we have the ovaries, which are the female gonads. They produce eggs and sex hormones. The oviducts, which are right here, it's an oviduct. The actual site of fertilization of the egg, in almost all cases, is the oviduct rather than in the uterus. Implantation of an early embryo occurs in the uterus. And fimbriae are those finger-like structures. They sweep across the surface of the ovary and most of the time pull that the ovulated egg into the fallopian tube. We also have, so we've got the uterus, the cervix, and then the vagina. So in this image, you can see a little bit more clearly the fimbriae of the oviducts. And here we see an ovary, what it looks like from the outside. This one is a frontal section through it. We've got the uterine ligament here, and this is referred to as the broad ligament. And again, that sort of helps to anchor things in place. So you've got the cervix here and the vagina, which contains rugae, ridges that allow for expansion. One of the cool things about the fallopian tubes is that the inner surface is lined with cilia the cells have cilia. And so the cilia are beating toward the superior aspect or edge of the uterus on both sides. And there's some smooth muscle associated with the oviduct as well that helps to propel the egg toward the uterus. So ovaries contain structures that are referred to as follicles. And within each follicle is an immature egg, which is called an oocyte. At puberty, women have about 300 to 400,000 follicles, each of which has an oocyte within it. Once a girl has reached puberty, one follicle a month, the egg in one follicle every month matures until menopause. So that during the lifetime of a female, only about 400 follicles mature. Ovulation refers to the monthly release of a mature egg or oocyte from the ovary when the follicle ruptures. And this is an actual image of a human ovary. Different cells in the ovary produce the sex hormones estrogen and progesterone. So in this image, we see some of the internal reproductive structures of female. We've got the uterus here. Let's see. Got a fallopian tube here. Ovary. Part of the broad ligament. And the ovarian ligament. And fimbriae, although you can't see them very well. So as I said earlier, the uterus is a three-layered structure. It's very muscular, smooth muscle, which remember is involuntary, and it's lined with a layer of epithelial cells called endometrium. The cervix is the opening into the uterus, and it is normally the opening is normally occluded or blocked by fairly thick mucus. When a woman is pregnant, that mucus becomes even thicker. During childbirth, the positive feedback cycle between oxytocin and stretch receptors in the cervix are what leads to dilation of the cervix. And the vagina is both the copulatory organ in females as well as the birth canal. So this is a mid-sagittal section rather than a frontal section. And most of this is labeled. So you have the pubic symphysis here, the bladder with the urethra. You've got the uterus, the cervix right in this area, and then the vagina with the what's called the vestibule of the vagina, or the entrance to the vagina, the labia minora, and then the labia majora, the anal canal, the rectum, sigmoid colon. Let's see what else. Got the sacrum. Oops, I went a little too far there. The sacrum here, and the coccyx here. So the external genitals of females include the labia majora or labia major, which are the two outer folds of fatty skin, and they are the same embryonic tissue that the scrotum is made out of. The labia minora or labia minor, which are just inside that, and they contain the openings to the vagina and the urethra. And just above the urethral opening is the external part of the clitoris, the glans clitoris. The mons pubis is, in both males and females, sort of a fatty pad that has skin with coarse hair. The clitoris in women has been rediscovered any number of times. It's actually quite a bit larger than most of us are used to thinking about it. So there's the tiny bit that you can see from the outside, but everything in this lower image that is sort of tan or different shades of pink is all part of the clitoris. You've got the opening to the vagina right here, and the urethral opening right there, and then sort of the outline of the labia as well. So fertilization, as I said in the first part of this lecture, is when you have a return to diploidy, because the haploid sperm and a haploid egg come together to form a zygote, which is a fertilized egg. Definitely know that vocab word, the zygote. It normally happens in the oviduct. Pregnancy does not technically begin with fertilization. It begins with implantation of the 6-day-old embryo into the wall of the uterus. And in part that's because so many fertilization events do not result in pregnancy. So when you have ovulation, you have a rupture of a mature follicle and release of an ovum. The fimbriae sweep that into the oviduct or fallopian tube or uterine tube, and someplace in here is where fertilization usually occurs. So the sperm have to swim upstream, up through the uterus, through the fallopian tubes, against the tide, if you will, of the cilia beating toward the uterus. So this is just showing you different stages of both the ovarian cycle here, and then after ovulation, when you have the mature egg, you have fertilization here, and then the first cell division. So you come to the 2-cell stage and the 4-cell stage, the 8-cell stage, until between days 5 and 8 is about when implantation occurs. An ectopic pregnancy is a pregnancy that implants any place other than in this general, actually not even that low, in this part of the uterus. Right? If the embryo implants lower in the uterus, closer to the cervix, it's likely that the placenta would rupture, which is cause no end of headache. Ectopic, by the way, means out of place. Remember that the uterus, the ovary is not directly attached to the fallopian tube. So when ovulation occurs, the egg can be, if it's not swept up by the fimbriae and essentially captured, you can have implantation on the outside of the oviduct or someplace in the abdominopelvic cavity. You can have implantation that occurs in the tube or just as the fallopian tube enters the uterus, and all of those pregnancies are going to be non-viable. I guess H here must be implantation on the outside of the uterus. So this is a sagittal section of non-pregnant and pregnant woman. And you can sort of see why the placenta is up at the top here. Why, if you have a placenta down here, the woman's at risk for severe bleeding once labor starts. You can also see, by looking at this, why women who are pregnant have to go to the bathroom all the time, because the uterus sits right on top of the bladder. Pregnant women have lots of heartburn. Again, there's only the lower gastroesophageal sphincter that keeps chyme from coming up into the esophagus is going to be, it's going to have a difficult time remaining closed when so much is pushing up. Most women, particularly late in pregnancy, have difficulty, not difficulty breathing, but they have a harder time breathing, and that's because it's much harder to increase the size of the thoracic cavity, because there's a lot more in the abdominopelvic cavity.
Fertilization is the epic story of a single sperm facing incredible odds to unite with an egg and form a new human life. It is the story of all of us. During sexual intercourse, about 300 million sperm enter the vagina. Soon afterward, millions of them will either flow out of the vagina or die in its acidic environment. However, many survive because of the protective elements provided in the fluid surrounding them. Next, the sperm must pass through the cervix, an opening into the uterus. Usually, it remains tightly closed, but here the cervix is open for a few days while the woman ovulates. The sperm swim through the cervical mucus, which is thinned to a more watery consistency for easier passage. Once inside the cervix, the sperm continues swimming toward the uterus, though millions will die trying to make it through the mucus. Some sperm remain behind, caught in the folds of the cervix, but they may later continue the journey as a backup to the first group. Inside the uterus, muscular uterine contractions assist the sperm on their journey toward the egg. However, resident cells from the woman's immune system mistaking the sperm for foreign invaders, destroy thousands more. Next, half the sperm head for the empty fallopian tube, while the other half swim toward the tube containing the unfertilized egg. Now, only a few thousand remain. Inside the fallopian tube, tiny cilia push the egg toward the uterus. To continue, the sperm must surge against this motion to reach the egg. Some sperm get trapped in the cilia and die. During this part of the journey, chemicals in the reproductive tract cause the membranes covering the heads of the sperm to change. As a result, the sperm become hyperactive, swimming harder and faster toward their destination. At long last, the sperm reach the egg. Only a few dozen of the original 300 million sperm remain. The egg is covered with a layer of cells called the corona radiata. The sperm must push through this layer to reach the outer layer of the egg, the zona pellucida. When sperm reach the zona pellucida, they attach to specialized sperm receptors on the surface, which triggers their acrosomes to release digestive enzymes, enabling the sperm to burrow into the layer. Inside the zona pellucida is a narrow, fluid-filled space just outside the egg cell membrane. The first sperm to make contact will fertilize the egg. After a perilous journey and against incredible odds, a single sperm attaches to the egg cell membrane. Within a few minutes, their outer membranes fuse and the egg pulls the sperm inside. This event causes changes in the egg membrane that prevent other sperm from attaching to it. Next, the egg releases chemicals that push other sperm away from the egg and create an impenetrable fertilization membrane. As the reaction spreads outward, the zona pellucida hardens, trapping any sperm unlucky enough to be caught inside. Outside the egg, sperm are no longer able to attach to the zona pellucida. Meanwhile, inside the egg, the tightly packed male genetic material spreads out. A new membrane forms around the genetic material, creating the male pronucleus. Inside, the genetic material reforms into 23 chromosomes. The female genetic material, awakened by the fusion of the sperm with the egg, finishes dividing, resulting in the female pronucleus, which also contains 23 chromosomes. As the male and female pronuclei form, spiderweb-like threads, called microtubules, pull them toward each other. The two sets of chromosomes join together, completing the process of fertilization. At this moment, a unique genetic code arises, instantly determining gender, hair color, eye color, and hundreds of other characteristics. This new single cell, the zygote, is the beginning of a new human being. And now the cilia in the fallopian tube gently sweep the zygote toward the uterus, where he or she will implant in the rich uterine lining, growing and maturing for the next 9 months until ready for birth.